Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIEVS Home School. I am Sabreena, Haque, Assistant Teacher of Science, National Ideal English Version School, Day Shift. Dear student, today I am going to take a chemistry class for class 9 student on the based on the second part of the chapter 4, and along with this we will discuss the two creative of the exercise. So dear students, let us move forward to this topic. The name of the chapter is periodic table. Today we will start from the periodic properties of the element. The element in the periodic table have some properties like metallic properties, non-metallic properties, atomic radius, ionization energy, electronegativity, electron affinity, etc. These properties are called periodic properties. First one, metallic properties. Elements which are glossy produce metallic sound when struck and conductor of heat and electricity. We call them metal. Modern definition goes the electron that turns into positive ions donating one or more electron are metals. This property to donate electrons by the metals is called metallic property. The more an electron element is prone to donate electrons, it is regarded to be endowed with more metallic property. Lithium is a metal as it donates an electron and becomes lithium cation. Lithium, that means lithium become one positive charge ion and it give up one electron. Any period in the periodic table has got the most metallic on the left. Gradually elements are less metallic as the period extends to the right. Come to the next one, non-metallic properties. Elements which are not glossy, don't produce metallic sound, and non-conductor of heat and electricity are called non-metallic. In the modern technology, the elements which turn into negative charged ions accepting one or more electrons are called non-metallic elements. This tendency to accept electrons is called their non-metallic property. The more an element is prone to accept electrons is to regard to be endowed with more non-metallic property. Chlorine is a non-metal. It accepts an electron and becomes chlorine anion. Any period in the periodic table becomes more non-metallic as it extends to the right. Some elements are there which sometimes behave like metal and sometimes behave like non-metal. They are called submetal. According to modern definition, elements that sometimes tend to donate electrons and sometimes accept electrons are called submetals. Silicon is a submetal. In the periodic table, the left period are metals, middle periods are submetal, and right side periods are non-metal. Now come to the atomic radius or size of atom. The size of atom or the atomic radius is a periodic property. The more a period progress from left to right, the size of atom or atomic radius decreases. Again, vertically in the periodic table, the lower we go from the upper part, the size of atom increases. In a period, the more we move to left to right, the atomic number increases but the shell number remain unchanged. As the atomic number increases, number of proton in the nucleus increases. So do the number of electrons, the attraction between the proton and electron increases. The number of electron and proton also increases, resulting the electron containing shell getting closer to the nucleus. As a result, atomic radius decreases. Again, in the same group, the lower we move from the upper part, a new shell is added with the outer layer. This added shell increases the size of atom. Noteworthy, newer shell increase the size of the atom more than the added electron, and proton decrease the size. Now if you observe from left to right, if we move in a periodic table, in a period the size of atom decreases, and if we move from up to bottom, top to bottom, the size of atom increases. Ionization energy, the energy that is required that is required to transform an element into 1 mole positive ion, removing 1 mole electron from its 1 mole atom in its gaseous states is called the ionization energy of that element, and it is the periodic property. In the same period, the element of the left side have greater radius than those of the right side. When the atomic radius is less, the ionization energy is greater, and vice versa. That means when the atomic size is less, that time the ionization energy will be greater. Now come to the example. Ionization energy is silicon greater than sodium and magnesium and aluminium, because the atomic radius of silicon is the smallest among these elements. On the other hand, sodium having the biggest radius among them and endowed with the least ionization energy. Now come to the electron affinities. The energy emitted when we try to transform an electron in its gaseous states into 1 mole negative ion by injecting 1 mole electron into its 1 mole atom is called the electron affinity of that element. It is a periodic property. In the same group, the element of the left side have the greater radius than those of the right side. When the atomic radius is less, the electron affinity is greater. The ionization energy and the electron affinity is same for the radius of the atom. That means if the radius will be less, the ionization energy and the electron affinity will be greater. Of the element barium, calcium, then strontium, magnesium, radium, some display greater electron affinity and some lesser. All these elements belongs to group 2. Then barium among them has got the lowest atomic radius, and that is why its electron affinity is higher. And again, radium among them has the highest radius and the least electron affinity. Now come to electronegativity. When two atoms turn into a molecule by covalent bond, the atoms is that molecule attracts the electrons towards themselves. This attraction is called electronegativity, and it is a periodic property. In the same period, electrons of the left side have a greater radius than those of the right side. When the atomic radius is less, the electronegativity is greater, and vice versa. For example, the sodium atom in the period 3 of the table has the least electron negative attraction, and the chlorine has the most. Come to the special names and the of the elements present in the various groups. The elements were bestowed a special name at the different times based on their physical and chemical properties. Apart of metals, non-metals and submetals already discussed, there are also some others. First one is alkali metal. There are 7 elements in group 1. Apart from hydrogen, the 6 other elements are lithium, sodium, potassium, rubidium, cesium and francium. They are called alkali metal. They are thus called since all of them soluble in water, and when dissolved in water they produce hydrogen gas and alkali. Now next one, that is the alkaline earth metals. The periodic table contains 6 elements: beryllium, magnesium, then calcium, strontium, barium and radium in the group 2. These elements are called the alkaline earth metal. They are available in various compounds in the soil, and all of them produce alkali. That is why they are grouped under the alkaline earth metals. Now come to the coin metals. Copper, silver, gold and roentgenium are 4 metals belonging in the group 11. The first 3 of them are called coin metals as they were used to produce coin from the ancient age and were used as the means of trade and commerce. Now come to the halogen group. 6 elements of the group 17 are called halogen. They are fluorine, chlorine, bromine, iodine, astenine and tungsten. Then the meaning of the halogen is the salt maker. Metals bonding with these elements produce salt like sodium and fluorine bond together produce sodium fluoride and sodium chloride together produce sodium and chlorine produce together sodium chloride. Both are the salt, and main source of halogen is the sea salt. They themselves produce diatomic molecules by sharing electrons like chlorine 2, iodine 2, etc. Now come to the inert gas. The elements belonging to group 18 are called inert gases. They are helium, neon, argon, krypton, xenon, radon and organeson, and as their outermost energy level is filled with the electrons, they do not show any tendency to form compound by accepting, donating or sharing electrons. This inaction in chemical reaction or chemical bonds gives them their group name. They remain in gaseous form at normal temperature. Now come to the transition element. Elements of group 3 and group 12 are known as transition element. Compound produced with these elements get same color. These transition elements act as catalyst in chemical reaction. Nickel of group 10 is an example of these kinds, which is used in various organic reaction. Now here they give a problem that why is the calcium called the alkaline metal. The answer is different compound of the metals calcium are available in the soil, which makes it an earth metal. Again, hydroxide compound of calcium is calcium hydroxide is an alkali, therefore it is also alkaline. Together these two information contribute in calcium being called an alkaline earth metal. Now come to second question, why helium is an inert gas. Explain. Helium does not bond with other element of its group, neither it interested to bonding with other elements, so helium is an inert element. Since at normal temperature it remains in gaseous form, so we called it an inert gas. Now come to the advantages of periodic table. The periodic table is a has a high significant contribution in various chemists of the different ages. Practice of chemistry is not possible without the modern periodic table. Some advantages of the chart is presented below. To simplify the study of chemistry, we know that a total 118 elements have been identified till 2016. If we consider only 4 physical properties, melting point, boiling point, density and state of matter, the 4 chemical properties, that means reaction with oxygen, water, acid and alkali, then that turns into 118 multiplied with 4 plus 4 is equal to 944 properties for these elements, and it is impossible to remember all this information. The periodic table has simplified that task. If we have know the common properties belonging to each group in a table, we will also be aware of the common properties of all these elements. Again, since we will be familiar with the common properties of the elements, we will also know the properties of the compound made with them. Now come to the detection of new element. There were some blank cells in the periodic table even some decades ago. The periodic table gave a prior idea about the elements that we accommodating those cells and their properties even before they are Okay, sorry student, before they were detected. You have already known that the Mendeleev has mentioned about the 4 elements in his periodic table which were later detected. Third one, in research, the periodic table has a large contribution in the field of research too. Suppose a scientist is interested to invent a new method to meet up a specific purpose. In that case, he must have some conception about what the properties would be new matter and what kind of element will be able to produce the new matter. He will get this idea from the periodic table. Now, you will gradually come to know about the later advantage of the periodic table. Now come to the next lesson, reacting occurring the elements the same group. Now an experiment will tell you that elements of the same group exhibit the same kinds of properties. The gases fluorine, chlorine, bromine, iodine are belonging in group 17 reacts with hydrogen and produce hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide gases respectively. Now this is the chemical reaction. Hydrogen and fluorine react with each other and form hydrogen fluoride gas. Hydrogen and chlorine react with each other and form hydrogen chloride gas. Now again, if we dissolve these produced gas into water and they produce the hydrolite acids like hydrofluoric acid, hydrochloric acid, hydrobromic acid and hydroiodic acid, like hydrogen fluoride plus water from hydrofluoric acid, hydrogen chloride plus water, it produce hydrochloric acid, hydrogen bromide gas react with water and is produce hydrobromide acid, and this hydrohalide acids react with any carbonate salt and produce carbon dioxide gas. Calcium carbonate and hydrofluoric acid produce carbon dioxide. This is the chemical reaction of the calcium carbonate and hydrofluoride acid, and from the calcium fluoride gas, then carbon dioxide and water. The same kind of reaction will take place in hydrochloric acid. Hydrochloric acid react with calcium carbonate and produce calcium chloride and carbon dioxide and water. So above the reaction convince you that the element of group 17 exhibit the same properties, and reaction magnesium and calcium of the group 2 also exhibit the same properties, and the reaction the magnesium carbonate in its reaction with light hydrochloric acid produce magnesium chloride, water and carbon dioxide gas. The calcium carbonate in the same reaction produce calcium chloride, water and carbon dioxide gas. If we observe in the same groups, show the same types of characteristics and make the similar characteristics thing, and there they give a experiment how we can produce the carbon dioxide. You have to learn this, and this is your important part for learning also. Now come to the exercise multiple choice question. The first question, the main basis of the modern periodic table: atomic number, atomic mass, relative atomic mass and electronic configuration. Dear students, firstly, when the first periodic table made, that time Lavoisier said that about the first was taken about the atomic mass, then it is about atomic number. Now the modern periodic table is main basis is the electronic configuration. And come to the next one, A. The element A is the electronic configuration of element A: 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 and 4s2, which groups is periodic table goes down belongs to their students, this 4 is indicate the period number, and if the electron goes first the s orbital, then it comes to the d orbital, then we have to add the d orbital's electrons number and s orbital electrons number, that is 3 plus 2 is equal to 5. That means it is belongs to group 5. Now comes to it that it is an intersection of the group from the periodic table, that is first one calcium 19, then second one X37 and Y55. Then here X and Y is the symbol, they do not represent the actual element. Now which pairs of the periodic table elements belongs to, dear students? Then X, the fifth periodic table, that fifth period the elements will belongs to. Now come to the next one, that is the shown elements have one electron in their outer shell, then the elements in their outer shell, then atomic radius decreases as we go from the top to bottom, and the elements Y is the more active than element A, dear student, and the answer will be 1 and 3. Now come to the creative question of the exercise. The first creative question, here they give the stem sodium, magnesium, here chlorine, fluorine and bromine, and diagram of the stem is a part of the periodic table. First one, write down the Triers law. And then second one, why the barium called the alkaline earth metal. And then question 3, which of the elements in the stem is the biggest in size, explain. And last one, analyze the electron affinity of the element in the stem as we move to the periodically from left to right. The first one answer is scientist Sabreena found that the group of the 3 elements show the same kind of features. First he organized the elements into threes according to their atomic mass, and then he marks that atomic mass of the second element is the half or near about half of the summation of first and third element atomic mass, and it is known as Sabrena's law of triers. Now come to the question answer B. The periodic table consists 6 elements: barium, magnesium, calcium, strontium, barium and radium in its group 2. Then these elements are called alkaline earth metals. They are available as the various compound in the soil, and all of them produce alkali. Barium reacts with water and produce alkaline solution of barium hydroxide, and that is why they are grouped under the alkaline earth metals. Now come to the question answer of C. Which elements of in the stem is the biggest size, explain. In the stem, sodium, magnesium are in the third period and fluorine situated at the second period, bromine at the fourth period. Now sodium, magnesium and chlorine situated in the third period, fluorine second and bromine fourth period. We know in a period the size decreases, the atomic number increases. That means sodium and magnesium are in the third period, and magnesium is at the right of the sodium, and from the left to right they have to the atomic number of 12 and 11 respectively. The atomic number of magnesium is 1 greater than sodium, so the sodium is bigger in size than magnesium. Then the atomic radius of sodium is decimal 157 nanometer. The atomic radius of magnesium is decimal 136 nanometer. Again, in the case of the elements of the same group, there are addition of electron orbit or energy shell from the top to bottom. Thus the atomic radius increases. Fluorine's group in the fluorine is group 17 as the fluorine on the highest position of this group, and it has the smallest size, and atomic radius of the fluorine is decimal 071 nanometer, chlorine is decimal 099 nanometer, and bromine is decimal 114 nanometer. From the discussion above, we can say that the sodium is the biggest size here. Now D will be your homework. For this you have to follow the page number 72 for the electron affinities properties. You can write the answer, and you can write total answer from this book's page number 72, the para electron affinities. Now come to the second question. Here period 1, period 2, period 4, group 1, group 2, group 3. Here the elements name A, B, C, which is belongs to period 4, and group 1, B is group 2, and C is in group 3. Now first question is write down the modern formula of the periodic table, and B is why boron is called the alkaline earth metal. Then C is the explain the change in the size of the atom from A to B, and analyze the change in the ionization energy as we progress from A to C. Now come to the answer. The physical and chemical properties of the elements repeat periodically according to their atomic number. This is the modern formula of the periodic table. Now come to the next question answer. Why B is called alkaline earth metal? The element of period 4 and group 2 is the calcium. Or then all the elements of the this group are the earth metals. Calcium react with water and produce alkaline solution of the calcium hydroxide. Calcium plus 2 mole water, it produce the calcium hydroxide, which is alkaline, and plus it also calcium produce hydrogen. Then like all the elements of this group, calcium is called alkaline earth metal. And this question answer also is in your book page number 75. And question C and D is your homework. You will get the question answer of C in page number 71, the atomic radius and the size of the atom, and question answer D you will get in the page number 72, the ionization energy. Total para is will help you to write the question answer. Now dear student, this is your Eid vacations homework, and you have to write the question answer of D of CQ once, and question answer of C and D of CQ 2. Along with this 2 question answer, you have to write that you have to make the 10 MCQ with 4 options and submit on 29th May from 9 AM to 3 PM. Dear students, I have finished my today's topic. Read the chapter so properly and do the SW. Thank you. Allah Hafiz.